Okay, so this is quiz 7. This is the first question. Find the critical value for this that corresponds to the confidence interval 89%. So this is two-tailed, meaning, and the confidence interval is 89%. So each tail, both tails are 11%, right? 1 minus 89%. So then one tail would be half of 11%, which is 5.5%. So 5.5% is the area to the right of this z value. So the area to the left would be 1 minus 5.5%, which is 94.5%. So we go to the table and find where we see 94.5. Okay, it's actually right here, 94.5. This is a little less, so 94.5 is right at 1.60. So the answer to this would be 1.60. Okay, next question. This is question 2. So here, since we know the sample size, which is 20, we can figure out the degree of freedom, which is going to be 1 less, so that's 19. So when we have the degree of freedom, we can just come up with the critical value for t from the table. So looking at 19 here, 19, and it's two-tailed, so looking at area in two tails at the 95% interval, and you see this number corresponding 2.093, which is going to be the answer here. Okay. So looking at the third question here, which one is not a property of the t-distribution? So the very first choice here, the standard deviation of a t-distribution is not always 1. There's actually a formula which has to do with the sum of differences of each point and the sample mean divided by the degrees of freedom. So this is not always 1. So that's not correct. So it would be A. Problem number 4. So in this one, we're given 40 students. So that's the sample size. So you can tell the degrees of freedom would be 1 less, 39. And we can easily find the critical t-value. The sample mean is given, and the sample standard deviation is given, and the confidence interval is 90%. So here, to find this confidence interval for the population mean, we need to use this formula here. So since we're given the, over here, the sample mean, 60.7, we just need to figure out the margin of error, and that can be figured out using this formula here. So all we need to do is figure out the t-value, s, and they're all given. So let's figure out the t-value first. Again, keep in mind 90% confidence interval, and degrees of freedom is 40 minus 1, 39. So 90% is this column, okay? So looking at 39 degrees of freedom, so it's right here, see 39, this column, it's 1.685, 1.685. So I put that here, 1.685, this is your t-value. 10.2 is the sample standard deviation that was given in the problem. And this is the square root, you can see the formula bar, square root of 40, which you can see from this formula. So the t-value, which is here, times s divided by square root of n. S is here, square root of n is here. So I have Excel do this calculation, multiplying the t-value by the standard deviation divided by the square root of sample size, which gives this margin of error. So this number, roughly 2.7, is the value of E here. Okay, so now all I have to do is take that value, 2.7, subtract it from the population, the sample mean, and write it on the left side of the mu, and then add it and write it on the right side. So this, again, I had the formulas do this. 60.7 is the sample mean, minus that gives us 57.98, almost like 58, and this is needs to add it, which is 63.4. So that's basically what goes on either side of this confidence interval. So then down here, it was saying the students participated for 1 minute 60 seconds, and because 60 seconds falls within the confidence interval, so the confidence interval includes 60 seconds, we say yes, it's likely that the students are reasonable estimates. So we would mark C. So in number 5 here, this confidence interval is given. So this value is already P plus E, or P hat plus E, and this is P hat minus E. So if I add these two values, I basically get 2 P hat. So add these two and then divide them by 2, you get the value of P hat, which you can write right here. So let's do that. 0.999, 0.555, add these two. So that's their sum, and that's equal to 2p. So just take half of that, and 0.777 is the value of p hat. So it goes right there. And then if I actually subtract these two values, since this is p hat plus e, p hat minus e, if I subtract them, the p hats will be eliminated and you end up with 2e. So again, do the same thing. This time, instead of adding them, subtract and divide by 2, and you get the margin of error, which goes to the right side here. So let's do that here. This minus that, and then take half of that. So 0.222 goes right there. Okay, so number 6. So this is actually pretty much same as one of the previous problems we did. You have the confidence percentage, you have the sample size, so degrees of freedom would be 51 minus 150. So you go to the t distribution table and find the t value for the two-tailed 90% confidence interval. And then once you have the t, this you have the s given, s divided by square root of 59 multiplied by that t value. That's going to give you the e, margin of error. So you would have to add that margin of error to the sample mean 2 and put it on the right side here, and then subtract it from 2.0 and put it on the left side here. And whether or not the given value falls within that confidence interval, you just say make a determination based on that. Oh, actually here it's asking if the confidence interval is affected by the normal distribution. So here this has to do with the sample size being large enough or not, and 51 is large enough, so it's not affected. You can put C for this particular sample size. So the next one seems to be a pretty simple one. We have the number of people, so the sample size is given the confidence interval, since you have the percentage and the margin of error, the confidence interval is given, but it doesn't say anything about the confidence level. So I think that's the one that's omitted. So you would say the confidence level. So this problem is asking us to find the minimum sample size required. So I'll let you read the question, but here is the formula we need to use to find the minimum sample size required. That's n here. This is the formula, which is the z-score times the standard deviation divided by the margin of error, this whole quantity squared. So this question gives us everything we need to know to figure that out. So first off, it says that 90% confidence. So the confidence interval is 90%. So since this is two-tailed, you've got 5% to the left, to the right of this critical value. So the area to the right of this critical value would be 5%, which is 0.05. But z-score denotes the area to the left, which is 1 minus 0.05, and that's 0.995. So we look for 0.995, and which z-score corresponds to that value in this standard z distribution. So 0.995. So 0.995. Sorry, 0.95. Because the confidence interval is 90%. So the remainder is 10%. Two-tailed divided by half, so it's 5%. 5% is 0.05. And 1 minus 0.05 is 0.95. Right, so we're looking for 0.95. So if you look here, this is 0.9495 and this is 0.9505. So 0.95 is exactly in the middle of these two. So this is row 1.6, 1.6, and 1.6 right in between 4 and 5, so it needs to be 1.645. So put that on here, 1.645. That's the z-score. That's the z-score. This is the standard deviation, which is 197 given in the problem. And E, margin of error, is 13. That was also given. So what I do is multiply these two, z times standard deviation rho divided by the margin of error, and here, see, these two multiplied divided by that, it gives me, it's like almost 25, but this quantity needs to be squared, so I square it right here, CG5 squared. So when that's squared, it's 621.4. Back to the problem, 621.4. So the minimum sample size needs to be a whole number, so we round up. So it needs to be 622. And major obstacle to getting a good estimate of the population mean. So we would say it's difficult to precisely measure, invalidating some data values. So that would be the most appropriate. So in this question, you're being asked to find population proportion, and you're given the margin of error and the confidence level. P and Q hats are unknown, so you can easily find the n here using this formula right there. You should be able to figure out the z value here based on the confidence level, 95%. Square that times by 0.25 and then divide it by the margin of error squared.